In this video, we will look at the maximum depth of binary tree question and plan an algorithm we can use to solve it. The problem poses the question: given the root of a binary tree, return its maximum depth. Furthermore, we are told that a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Usually tree questions involve a traversal or searching algorithm, and the two that usually come up are depth first and breadth first. A depth first traversal goes deep, visiting child and grandchild nodes before visiting a node's neighbors. In contrast, a breadth first search visits all of the neighbors before the children and grandchildren. To solve this question, a depth first algorithm would be the appropriate strategy to use, since the question is asking us to find the maximum depth. In this video, we will look at the balanced binary tree question and plan out an algorithm to solve it. The problem statement tells us, given a binary tree, determine if it is height balanced. We are also given the definition of a height balanced binary tree: a binary tree in which the left and right subtrees of every node differ in height by no more than 1. We will need to determine the height of the subtrees, and then check that the absolute value of the right and left subtrees is less than 1. We will also need to make this check recursively on the right and left nodes' subtrees respectively. In this video, we will look at the path sum problem and plan out an algorithm to solve it. The question says, given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. We can solve this question by using a depth first algorithm that executes recursively.